I say, you know what are sets, right?
Yeah.
So what is a relation then?
Relation to sets.
Yes. If you have
It's
to
when
define, yeah, go ahead.
I mean sets is just when an element belongs in another like subset or another group.
So set is a collection of well-defined objects. This we talked about. And
Yeah.
then let's say I have this set of natural numbers. So countably infinite. Now I have another set which is the set of even numbers. So
Yeah.
if I want to say that there is a relation between A and B, I can see that I can get the elements of B by multiplying them with 2, right?
Yeah.
So I can say that uh, relation R, which is defined from A to B. A to B means it will be in the form of ordered pair, x coordinate, y coordinate. And always the x thing should come from the first set and y thing from the second one. So if I say 1 comma 2, that means 1 is from A set and 2 is from B set. So I'll write it this way. R is defined from A to B. And if you have to write this R now, which is ordered pair xy, such that x belongs to A, y belongs to B. Okay. So this is the form which we can say set builder. If I have to, this is set builder. Set builder form. If I have to write it in what you say, roster form, how would I do that? So for that, I simply pair them up. So I know 1 is going to map with 2, 2, 4, P6, 4, 8, and whatnot. Is it clear?
Yeah.
Yeah. Now, as you can see, I have some terminologies from this set, which is firstly domain. What do you mean by domain?
It's like the range of x values, like what are the x values?
Yes. So it is a collection or the list of all x of the elements from set A. I'm talking about this specific thing, A to B when it is going. Collection of the elements in the set A. What is codomain?
Um, all the y values.
Yes. Not exactly Y, actually collection of, okay, Y values in what? In the
As in
relation.
like if the function is f of x, then all the collection of the f of x values.
Yeah. So at the moment we are not talking about the function, it's relation, collection of all the elements in the set B.
Yeah.
Now there is a difference when I say Y and when I say set B. Because you can see, let's say I am cutting it short. I'm saying that this is my R, only this. So now the range is the collection of Y in the relation. So you will say that range here is this 2, 4, 6, 8. But codomain here is the whole of B set, all the numbers 6, 8. Are you getting my point?
Yeah.
Domain is what you have here in the set, only in the relation form. If I have to map it, I use arrow diagrams for it. So just like Venn diagram is there for representing sets, we have arrow diagram for the relation. So I'll mark x coordinate. I mean, I have all those A, B elements here. But I'll mark only those which are mapped in relation and I'll call it R. So this is from 1, 1 is mapped with 2, 2 is mapped with 4, 3 with 6, and 4 with 8. Okay.
Yeah.
Now I have, okay, if there's one question that, let's say if relation 2, 4, 2a, b6 is equal to a plus b 5 and 7 minus a, what do you say? 6. What are the values of a and b? What do you say? Can you see these are ordered pair?
Yeah.
So ordered pair can only be equal when x component is equal to x and y component with y. Okay? So you have to equate them. Let's say if I consider only one, this bit, that these are equal. So I'll say that, okay, this
So
first
A
part
plus
will,
B equals to 2.
yes. And then b becomes 2 minus 5 minus, right?
Yeah.
How many total ordered pairs a relation can have? For example, in set, if I say that you toss a coin twice, and I know when you toss it once, you get head and tail, that is two outcomes. So what you do, these are two, so 2 raised to power m. M is number of times you are tossing it or an event is occurring. So two elements are there. I'll say 2 to the 4. Twice you are tossing it. 4 outcomes have to be there. So you'll write head, 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 tail, tail, head, tail, tail, right? Right?
Yeah.
But when it is relation, you will see that how many elements A has, how many elements B has, and then you simply multiply. So these are 3, these are 2. So 6 elements your relation will have. How? Because if you are moving from A to B, so it will be 1 can be mapped with 2 and 4. Am I audible?
Yeah.
Okay. Then 2 can be mapped with 2 and 4. And then so as for 3, 3 can be mapped with 2 and 4. So you can see 6 elements are there, right?
Yeah.
And then if you want to know how many subsets it will be having, subsets of a relation, that is 2 raised to power the number. So it has 1, 2, 3, 4, 5, 6 elements. So 2 raised to power 6, which is 64. How? So you know that a set is the subset of itself. So this will of course lie here. Phi is the subset of every set, 2 down. And then every particular singleton set, that is elementary set, element, all those elements will form one set, right?
Yeah.
And so as you will be having the pair 1 2 1 4, these combination, then you will be having triplets and their combination. So in that manner, you will get 64 values. Are you getting my point?
Yeah.
Now comes function. What is the relation? I mean, what is the difference between function and relation? What is a function?
Just an equation that if you put in the x value gets you to the y value.
Yeah. So basically, it is very important. The relation, the difference is, let's say I have written two things. One is 2 1, 2 2, and 3 4. And I have written 2 1, 3 1, 3 5, 4 6. This is not a function, but this is a function. And the reason being, if I'm saying that A to B, it is these elements are forming a function. Of course, we define function with the ordered pair, wherein x belongs to A, y belongs to B. If the function is moving from A to B, that is fine. Everything is same, the definition and all. But it is important. When I say, see, I have written 1 and 2. So how do I define it? 1 is the pre-image of 2, and 2 is the image of 1. So how do I call it? First thing is the, if you are moving from this way to this way, so 1 is the pre-image of 2. So y component is the image and x is pre-image. So in order to define function, it is important that no two same values have different y. That means if I map first one, if I draw this one, R1, let's say, I have 2 and 3 x values, and here 1, 2, 4 as y values. I'll see that it is 2 with 1 and 2 with 2 and 3 with 4. It is not 1-1 mapping. So relation becomes function only in that case when,
When it is one-to-one mapping.
yes, 1-1 mapping, no two image. For example, if I draw this graph and you have to find out whether it is a function or not. Tell me. This is a
Uh,
parabola.
yes, it is because every x has one y.
Perfect. So you can see that I have these two, but y is same. You cannot have Same x and different y's. Okay? For example, if I draw the parabola, if I rotate it and draw it this way, is this a graph? I mean, is this a function?
No, because um
For this x,
the x has two y's.
two y's. So it is not a function. So for
So
that,
basically, it's
yeah,
whether it's a function, you can just do the vertical line test, right? And it should
perfect.
pick up the graph one time.
Perfect.
Okay.
It is vertical line test which defines it that whether it is a function or not. Now, another thing is, I mean, how many types of functions are there? First is 1, 1 or 1 to 1, or we
Yeah.
call it injective.
Yeah, I learned these yesterday. They're so confusing.
I'm telling you. So 1 to 1, what's the name suggest? 1 to 1 means
That there's
everyone.
one part value
Hmm. So what is
for
happening? Perfect. For every,
x, for every one x value.
yeah. So 1 on 1 or 1 to 1 or injective function means you have single values. Everything is mapped. This one, this one, this one. Also, you will see for being a function, there should be one more condition to be satisfied. If you have x, I have two situations. Exactly same thing, but let's say I have this, and I have this, and one more. Uh, so this is not a function. These are. Can you tell me what is the condition which is not making this case a function, but these are functions? Observe.
But why is it not a function then? Is it because everything in x has to have one value for all of y? So 1, 2, 3 has
Perfect.
to be connected to 4, 5, 6, and not just 1, 2 to 4, 5.
Nice observation. This is exactly the answer. So every X should have its unique image.
Okay.
Unique as well as image has to be there. However, you can leave Y. That is fine. So Y can be left out because codomain and range can be different. But domain has to be same. X component has to be the domain. Okay.
Yeah.
Now come to this. So I have 1 to 1 function, which is injective function. You can see every element, as you know, we have here for these two x, same value of y, right?
Yeah.
So this is not 1, 1. This is a function, but this is not 1, 1. Okay. If one element is mapped with
Y
one,
has two x values.
yeah, y should not be repeated, x can be.
Oh, okay.
right?
So in a
Vertical line
okay,
test.
makes
Vertical line.
sense. Okay.
Now, so every element should have a distinct image in its codomain. Okay?
Yeah.
Then we have many one. Many one is also called as onto function. Oh, sorry. Onto is different. Many one function. So as the name suggests, this is many one, right?
Yeah.
Many values for x, but one value, I mean, they have same images. So for example, I have 1, 2, and I have 3, 4, 5. So 1 is mapped with 3, 2 is mapped with 3. Okay. So this sort of thing is many one. Is this fine?
Yeah.
If there are at least two elements in the codomain which are same.
Is this also a possible function?
It is a function because x can be repeated. Oh, it is.
Just one y.
Oh, sorry. Okay. And then what should we do? You can see I can combine what? There should be at least two elements in the codomain which has what?
Um, which have a corresponding x value.
Tell me one thing. X should not be repeated, but Y can be repeated, right? To be a function.
Yeah.
So is this fine?
Is it not the other way around though?
Just remember with the vertical line test.
Okay.
If you
Yeah.
have same X or same Y, it is not a function. But for same X, if you have this, it is not a function, right? X cannot be repeated for different images. Y can be repeated for different pre-images. Does this make sense? This is not a function because for one X, I have two values of Y. Here, here I have different X. No value is forming same, what do you call? No particular element here in codomain has same pre-image. So it is a function. Are you getting my point?
Yeah.
So if you have to write this way, 1, 3, 2, 5, 3, 3. So X is not repeating. So that means it is fine. It is a function. Here we were talking about this. There's are at least two elements in the codomain whose images are same. Then we'll call it many one. Okay. So these are many, but they are converging to one value. Are you getting my point? From the name, if you want to define. Is this fine?
Yeah. Okay.
Then we have very important onto function.
This is the surjective ones, right? Those are so confusing.
Yeah, it is subjective, injective and subjective. So you can remember you get into a room one by one. So injective. Onto a function is subjective. So what is it? You know, when I gave you this example that y can be left, where has it gone? Y can be left over without a preimage, that's fine. But this is not onto. For being onto, every single y component must be having its preimage. Okay? You cannot, I mean, if 6, whatever you have in y, the codomain set, it must be the range. When codomain becomes range, it becomes onto. Does this make sense?
Yeah.
So basically, onto means, so see, this is not onto, this is onto. So the function which is both 1 and onto, it is called as bijective function. Both 1 and onto. Are you getting my point?
So 1, 1, and then on to. Okay, so 1, 1 means that for one x there's another y, and then on to means that for every single x's there is one y, right?
No, for every y there is x.
Then
Y
what
is
is
not, yeah.
then what is 1, 1?
1 is you have to have only one mapping. So you cannot have, see, this is the difference. You cannot have multiple images. I mean, multiple numbers who have same images.
Right.
Does this make sense?
Yeah.
1 is something when you have, you are not repeating. You, because of course, x cannot be repeated to be a function. We are talking about y. So if y is not getting repeated for various x, then we will call it 1 to 1. And if it is repeating, we call it many to 1. And if there is no y which is left, so for example, you have this, you have this, you have this. It is 1 and on to both. But let me give you the example wherein it is on to but not 1. So I have, okay, can you see? X
Yeah.
cannot be repeated because then that will not be a function. But y can be repeated. And if y is repeating, it is not 1 now. It is many to 1. But it is definitely on to. Why? Because no y is left behind without having the preimage. Is this fine?
Yeah. But if it's only surjective, then that means that there's y for like that there's x for every single y.
Yes.
So it can also you can also have a surjective function without injective, right?
Yes. This is what it is. It is not 1, right?
Yeah.
So this is what we call not 1. The function which is both 1 and on to. This is very, very important. We have to prove it later on. That is called bijective function. Bi means two. Which two are involved? 1 and on to, sorry. And the function which is bijective, that will only be considered to have the inverse. So that is invertible function. Now, what is it I'm telling you? Invertible function, the function whose inverse exists. Inverse means, let's say I have A to B. Tell me, is it bijective function? Both one
Uh,
and on.
it should be bijective, right?
Yeah, it is bijective. So inverse will be, so function moves from A to B, but its inverse move from B to A. So now you will change the sides, though these are same. But can you see? This is F inverse, okay? In order to distinguish, let me write this. 246. Is this fine?
Yeah.
Now, why it is so that a function for being for having inverse the function has to be both 1 and onto. Why it is so? Can you figure this out from the figure?
Because then it means that when you replace the y with the x, there will be like for every y value, there will be another x value.
Perfect. Can you see here? When I have many to one, and if I flip it, so if I flip, my x value becomes this and y this. Now I'll map. So 1 with 1 and 3 with 2 and 3. Can this be a function? And 2 and 3 with 3. So 2 and 3 with 3 and 4 with 2. Can this a function now? I flipped them. Initially it was a function. Now this is not a function because my x are repeating.
Because then, yeah,
And if x are repeating, so x values are repeating, it is not a function. So inverse does not exist. Why? Because inverse means you are just flipping the sides. And if its existence vanishes because of that, you will not make that happen. So function was initially there. You cannot flip it like that. For flipping, it is important to have 1 and onto characteristics so that both this is also function, the inverse is also function. Then we say that inverse exists. Okay?
yeah,
Clear everything?
yeah,
Next type of function is absolute value function. You must have heard about it.
yeah. We did this on Monday.
Okay. Absolute value. So, for instance, let's say I have drawn this graph and I say that a bus is moving with some velocity and it is on the graph, let's say it is on the coordinate 3 comma 0, 3 comma 0. And now what happens? It starts moving from in the western direction. So 5 steps, 2, 3, 4 steps in the left. So I'll say -4, right?
Yeah,
-4 steps, or you will say the difference between if it was initially at 3, you will say 3 minus -2. So actually, it was 5 units distance, the difference, the displacement, right?
Yeah.
So if I'm drawing it on the graph, I can say that, okay, because left side, if you are moving, so we have to decrease the values. And because of that decrement, I'm having negative answer. But actually, in the real world scenario, you cannot say I walk -2 units. So negative sign should not be there. It is just to represent the direction that you are moving back and forth. So for that, I use absolute value. Absolute values, even if you are having -21 and you use this modulus, you can call it modulus or absolute value, you will get the positive outcome always. Okay?
Yeah.
So if I have to draw the graph, I'll say even for negative values, so for 0, I'll get 0. For -1, I'll get +1. For +1, I'll get +1. For -2, I'll get 2. For 2, I'll get 2. So this sort of graph, this V, okay? This V is
But
what we,
mine has been made positive because all the values are just positive, right?
yes, positive Y. It will, so I have first and third quadrant values for, first and second quadrant values for X, but Y remains positive, okay?
Yeah.
So how do we represent it? That is very important. So we write the function like this. So it is the value of y, like value of a function that is y, when you put x in the expression. So that means, let's say if I'm saying fx equals x plus 2 and you say x is 1, so I'll put in place of x 1 and simply by substituting I'll get the value for y. So my coordinate from here is 1, 3 because x is 1 and y is 3. So what we have in absolute value or modulus function? Okay. So when I represent it in the form of function, I'll say that the function will be having positive values for x greater than 0, 0 when x is 0, right? And even if you substitute any negative x, you can have negative x, that will also give me what? Positive values. Yes or no?
Yeah.
Then we have a constant function. So let me dig deeper to it. For example, I have an inequality and I have to solve it. I know that as soon as I remove this modular sign, because this value, the possibility is, it is positive x minus 2. Even if it is negative x minus 2, then also it is giving me the same answer, right?
Yeah.
So I'll be having two values from here. If I substitute x minus 2 greater than 3, so I'll get 3 plus 2, that is x greater than 5. This is one of the solutions. And then from here, if I substitute this negative, I mean, take it to that side, it will change the sign of the inequality, right?
Yeah.
Why it is so? Because let's say you are saying you have a number which is greater than 3. Assume you have a number greater than 3, that means it is coming to right hand side. It lies on the right hand side of the number line, right? Any number greater than 3, 3.1, 4, 5, 6, 10, 12. Now you change the sign, you multiply it by multiplier divided by x, by minus. You will see, because initially you tell me 3 is greater than 4, but minus 3 is greater than 3 is lesser than 4, but minus 3 is greater than minus 4, right?
Yeah.
Because minus 3 lies right side on the number line as compared to minus 4. So it will change the sign. So I have to change the sign, and then it will give me minus 3 plus 2. That is, so my answer is greater than minus 1, but less than, what is it? Greater than minus 1. And here, is this fine?
Yeah.
So this is something which is x is greater than 5. So this is very weird. You must be finding it. But on the number line, this is compound inequality. How will I draw it? This is minus infinity. This is plus infinity. So because both of them, none of them has equality sign, not this. So I'm just having the hollow circle and here as well. And then I'll shade the line. This is my solution graph. Oh, sorry. Hold on. It is what? Greater than,
Greater
it
than
is
minus one.
greater than 5 and less than minus 1. So this is the solution. Is this fine? I can say minus infinity to minus 1, union 5 to infinity. Is this fine?
Where it says the on the bottom left where it says x is more than 1, but x is also more than 5. Why is it written like that? Should it
This
not
one,
be? Yeah, why is that the sign? Should it not be the
yeah, I
other
mean, it is greater than 5. X is greater than 5, right? We don't write the compound inequality this way. So we have
Yeah,
to simply write, for example, x is less than minus 1, x is greater than 5, and you show this solution. Okay.
yeah.
Now comes constant function. Constant means, as you know, I have fx, but it is always fixed, for example. Fx is some constant. So for that, I'll always be having, so either you are changing the values of x, even if you are having 0, 1, 2, 3, you are getting constant y. For example, y is 3. 1, 2, 3. 1, 2, 3. Okay. So you are going to get this line. You see, even if you have different values of x, your y is going to be same, which is okay.
Yeah.
So this is called as constant function. Then you have identity function. Identity means exactly same. So if you are putting the value of x, you are getting x only. So here you have y equals x. Okay. So if I have to draw the graph, it will be this way. If you are having 1, then it will be 1. If you are having minus 1, y is also minus. Minus 2, minus 2. 2, 2. 3, 3. So it will always be a straight line passing through origin. Okay.
Yeah.
When you have a rational function, as you know, it is something ax plus b, pq plus r, some px plus r or p. It will be having fraction form, and the condition for that is denominator must not be equal to 0, can never be 0. It is very important because whenever you will find out the range and domain, for example, find the domain and range for the question given below.
Yeah.
I have x plus 2, and then I have 1 by x. Then I have 1 upon x minus 2. Then I have root x. So here, just see, domain is what? The value of x. What am I supposed to put in place of x? Is there any restriction that I cannot think of? That no, x cannot be this. Nothing is there. So x is all the real values which you can put if you have to define this for the real numbers. Okay?
Yeah. Okay.
But what is y then? If you substitute x as 0, it will give you 2. If you substitute minus 1, it will give you 1. If you substitute minus 3, it will give you minus 1. So y will also be having all of those numbers. So y is also all the real values. Okay? Yes or no?
Yeah.
But here, what can I not put is denominator can never be 0. So I'll write that domain, that is the x part, is every real number except 0. Is this fine?
Yeah.
But range is what? Range is the value of y. So
Range
for,
is real except cannot be 0.
sorry,
Range is real except it cannot be 0.
yes. No, firstly, domain is the value of x. And
Yeah,
x
yeah.
is what? One.
Domain can't be 0.
Domain cannot be 0. And what about the range?
Cannot be 0.
Yeah. So it will also be defined as. Tell me what about this one? X minus 2 is denominator. So it
X
cannot
cannot
be.
be 2.
So x cannot be 2.
And how do you find the range easily?
Okay. Firstly, you will be having this. So once you get that what x cannot be, that will be your domain. And you can write it in two ways. That real number minus 2, or you will say that it is everything minus infinity to 2, union 2 to infinity. So can you say I have picked this 2 and taken this, what do you call, open bracket? That is not inclusive, correct?
Yeah.
So this is also the interval sort of way to represent. And now the range. For range, I need y. So I'll simplify it to get the y. I'll take this there, 1 by y, x here, 1 by y plus 2. Now tell me what is the range? Y cannot be 0. Yes or no?
Yeah.
So I'll say that all the real numbers except 0 is the range. Any doubt?
No.
Now see this one, root x. I know that if root becomes negative, this is the concept of complex numbers. But we are dealing with real numbers at the moment, right?
Yeah.
So I'll say that x, either you can say x is greater than or equal to 0, or you will, yeah, equal to 0. So you just simply say this. So you will write 0 to infinity. Okay. And then if you have to find out the range, you need to find out the value of y. So squaring both sides.
Oh, so in order to find the range, you just put x on one side.
Yes, isolate the variables. So
Okay,
y
that's easy.
square, yeah, y
So
square is
y
equal
has to be greater or equal to 0.
to, I need to find out, huh, tell me, what can be range from here?
Y has to be greater than or equal to 0.
Perfect. All the positive numbers.
Yeah.
Is this fine?
Yes.
Then we have trigonometric ratios also, and exponential functions. Trigonometry, we will be having some sort of sine, cosine. How is your trigonometry?
Um, like it's easy to understand it, but some parts are hard. Like I struggle with how many answers are right
Oh,
and how do you
yeah.
know what answers are right? That's like extremely hard for me. The rest of it is fine.
Okay, getting you. We'll work on it. So anything when you have sine, cos, tan, cot, cosec, sac, anything from them is trigonometric ratio, a trigonometric function.
Yeah.
Anything which is their inverse is inverse trigonometric function. They also have graph. We'll talk about them. Here is cubic function. You can try to draw the graph of it. You will see this is something S sort of, because if you draw the graph, this is Y. You keep substituting negative and positive values. Negative 1 cube is negative 1 and 1. So you will see this, it will be something like this. Okay. So this is cubic polynomial, cubic function. Uh, this is how you can go ahead with the concepts. Tell me